Converting from radians to degrees. So in this example, we have to convert 117 pi over 30 radians to degrees. Okay, for this problem, we have to remember what is the relationship between radians and degrees, and that is that 180 degrees equals pi radians. Okay, or I like to abbreviate it like this: 180 deg for degrees equals pi rad for radians. Okay, so for converting between units, all you have to do is multiply by this relationship in the form of a fraction so that the units cancel. So let's do that. We have 117 pi over 30 radians, and we want to convert to degrees, so we have to then have the radians on bottom so they cancel and degrees on top. And now here we write the relationship, which is pi radians equals 180 degrees. Now you see that radians would cancel, and our job is then to simplify this, and that would be our answer. Note that the pi's also cancel. I can also cancel a 0. So this would be what? This would be 117 over 3 times 18 degrees. That's what survives, the 117, the 3, the 18, and the degrees. And we can simplify this a little bit more. We can cancel a 3, so that would be 6 right there. And then the answer would be 117 times 6. And let me put that in the calculator real quick to see what that is. 117 times 6 is 702. So this is 702 degrees. Convert 570 degrees to radians. Okay, so once more, what is the relationship between degrees and radians? 180 degrees equals pi radians. So multiply 700 degrees, and I prefer writing the word out so that I can see it canceling. So 570 degrees, and you multiply by the relationship between degrees and radians in the form of a fraction in such a way that the degrees cancel. So I need to put degrees on bottom so they cancel, and then that would mean then that radians goes on top. And the relationship is that 180 degrees equals pi radians. Okay, and now we just simplify to get the final answer. Degrees would cancel, and I could cancel a 0. And then multiplying across, this would be 57 pi over 18 radians. And I can cancel a 3. If you cancel a 3 from top and bottom, you would get 6. And 57 divided by 3, let's put that in the calculator, that is 19. So these would be 19. So that means the answer would be 19 pi over 6, and we don't have to write the word for the units. It's implicit. So that's the answer. Find the area of a sector of a circle. In this problem, they're giving us a circle of radius 13 kilometers, and a central angle of 21 degrees, and they want us to find the area swept by this central angle. So in other words, if you draw a picture real quick, okay, that's a terrible circle, but you get the idea. And suppose this is a central angle of 21 degrees. They're asking us what is the area of that sector. Okay, so this is just a fraction of the whole circle. Okay, so that means we first compute the area of the whole circle and then multiply by the fraction that corresponds to this sector. So let's start by finding the area of the whole circle. The area of the whole circle is pi r squared. And then to get the area of this sector, we multiply by the fraction corresponding to the sector, which in this case is 21 degrees over 360 degrees. If the angle had been given in terms of radians, then it would be over 2 pi. But is the quantity, the measure of that angle over the totality of the circle. The complete circle is 360 in degrees and 2 pi in radians. Okay, so now we just plug in what the radius is and simplify this, and that's it. So this is going to be pi times 13 squared times 21 over 360. And now let's enter this in the calculator. So we have pi times 13 squared times 21 over 360. We got 30.97. They say the instructions say round to 2 decimal places, so 97. This is area, so this is square kilometers. Converting from DMS notation, which is degrees, minutes, and seconds notation, to decimal notation. Okay, so in this problem we have 37 degrees, 23 minutes, and 34 seconds. To convert it to decimal, 37 degrees, 23 minutes, and 34 seconds, these will be the same as 37 plus the minutes. To convert it to decimal, you have to divide by 60 because there are 60 minutes in an hour. And then 34, to convert it to decimal, you have to divide by 3600 because there are 3600 in an hour. And then you enter all this in the calculator, and that's the answer. So let's see what we get. We get 37 plus 23 divided by 60 plus 3600, plus 34 divided by 3600. We got 37.39 to 8 because it says round to 4 decimal places. This is degrees. The sun is 15 degrees above the horizon. Find the length of a shadow cast by a park statue that is 10 feet tall. Round your answer to the nearest integer. Okay, for these type of problems, it's always good to start off by drawing a quick picture. So we have here, we can draw the ground. and its statue. We can draw the statue like a stick. And then the sun rays are shining down, and since the sun is 15 degrees above the horizon, that means that the sun rays actually fall at that angle. So that means this angle right here is 15 degrees. Okay? So this right here is a shadow. That's what we're trying to find. And this is the height of the statue, and they're telling us the height is 10 feet. Question is, how long is this shadow? So for this, we just have to think which of the basic three trigonometric functions, sine, cosine, or tangent, relates the shadow, which we're going to call it x, relates the shadow this side, which is the height of the statue, and this angle. So think which of the basic trig functions relates that side, and that angle. If you said tangent, then you're right. It is tangent. So we would get tangent of 15 degrees. So katoa, opposite, over, adjacent. So 10 over x. Okay, now to get x from here, you can just multiply both sides by x or cross multiply. You will get x tangent of 15 degrees equals 10. And then divide by tangent of 15, and you will get that x equals 10 over tangent of 15. That is the exact answer. They want us to round to the nearest integer, so let's put this in the calculator and find out how much this is. So this would be 10 divided by tangent of 15 degrees. Make sure though that your calculator is in degrees, not in radians. Mine is in degrees, so this is good. So we get 37.3. We have to round to the nearest integer, so that would be 37 feet. Okay. Now, in some variations of this problem, they could give you the length of the shadow, and they might ask you what is the height of the statue or of the tree or whatever. But still, it's solved exactly the same way. Find the reference angle associated with the given angle, in this case an angle of 845 degrees. Okay, I first have to remind you that there's two concepts regarding angles that we learn about. We have the so-called reference angles and the coterminal angles. Coterminal angles are two angles that when you draw them on the plane, they have the same picture. So they're pretty much indistinguishable because they look exactly the same. They have the same initial side and the same terminal side. And the reference angle, which is what they're asking about in this problem, is something else. It is, once you draw the picture, it is the smallest positive angle between the terminal side and the x-axis. Okay. Coterminal angles are used when you are dealing with an angle that is too big to begin with. Too big meaning outside of the circle, which is from 0 to 360, meaning, you do more than one revolution. If the angle is bigger than 360, that's kind of too big. And you can bring it down by finding a coterminal angle. In coterminal angles, you find them by either subtracting 360 or adding 360, okay, depending on what you need. In this case, this is too big, this is bigger than 360, so we're going to bring it down by subtracting 360. Okay, so let's start by making this angle smaller. It is too big. So if you subtract 360, you will get 485. So this is an angle that is coterminal, has the same picture, and it is easier to work with. But it is still too big because it is bigger than 360. So we can bring it down, make it smaller by doing this one more time. So subtract 360 again, and you get 125 degrees. And that is a coterminal angle, meaning that angle has the same picture as this one. So it is a coterminal angle, it is not the reference angle. For the reference angle, we need to draw a picture. Okay, so that's a unit circle. 125 degrees is on the second quadrant because it's bigger than 90, less than 180, so we draw it somewhere here, and that would be 125 degrees. Now, as I said at the beginning, the reference angle is the smallest positive angle between or formed by the terminal side, this side, and the x-axis. So there's two angles. There's this one, and there's that one. Okay, this is the x-axis, that's the terminal side. So there's two angles formed by the terminal side and the x-axis, that one and that one. The smallest of the two is the reference angle. So that means, in our case, the reference angle is not the blue one, it is the red one. It is this one right here. The question is, what's that? What is this? Okay, so this is almost 180. If I completed this by adding this piece, I would get 180. So it is 180 minus 125. The missing bit, this one, is 180 minus 125. And that is 55 degrees. So that is the reference angle. We typically draw reference angles in the first quadrant. And if you draw this reference angle, it will look just like a reflection right around here. Okay? So that would be 55 degrees.